evaluating location alternatives. Common techniques are cost, volume, profit analysis, factor rating, and center of gravity method. The cost, profit, volume analysis. The technique for evaluating location choices in economic terms. First, determine the fixed and variable cost for each alternative. Second, plot the total cost lines for all alternatives on the same graph. And then determine the location that will have the lowest total cost or the highest profit for the expected level of output. Assumptions. Fixed costs are constant for the range of probable output. Variable costs are linear for the range of probably output. The required level of output can be closely estimated. Only one product is involved. For a cost analysis, compute the total cost for each alternative location using the equation total cost equals fixed cost plus variable cost times quantity. FC represents fixed cost. V represents variable cost per unit. And Q represents quantity or volume of output. Let's take a look at an example. In this example, there are 4 alternatives, A, B, C, and D. Fixed cost per year for each alternative, and variable cost per unit for each alternative. From this table, you can calculate the total cost for each alternative, A, B, C, and D, using the total cost formula. And then draw a graph of the total cost of each alternative. In this figure, alternative A is a blue line. Alternative B is a green line. C is a black line. And D is a white line. The last step is to determine which alternative provides the lowest total cost. We have to look at each range of output. The first range, from 0 to about 5,000 units of output. Alternative B provides the lowest cost. The second range, between 5,000 and 13,000 units of output. Alternative C is the best. And beyond 13,000, alternative A is the best in terms of cost. To determine the exact range, we use the formula, the total cost formula of each alternative at the intersection. For example, at the first intersection of alternative B and C. That means at that point, the total cost of B and C are equal. Then solve for Q, and we get Q equals 5,000 units. At the second intersection, it is the intersection between A and C. Again, at that point, the total cost of A and C are equal. Solve for Q, and we get Q equals to 11,000 units per year. The second method is called factor rating. It is a general approach to evaluate locations that includes quantitative and qualitative inputs. Procedure 1. Determine which factors are relevant. 2. Assign weight to each factor that indicates its relative importance compared with all other factors. The weights typically sum to 1. 3. Decide on a common scale for all factors and set a minimum acceptable score if necessary. 4. Score each location alternative. 5. Multiply the factor weight by the score for each factor and sum the results for each location alternative. And 6. Choose the alternative that has the highest composite score, unless it fails to meet the minimum acceptable score. This is an example of using the factor rating method. As you can see, there are two alternatives here. The first column to the left is the factor column. For example, proximity to existing source, traffic volume, rental cost, size, layout, and operating cost. The next column is a weight. It is a weight that is assigned to each factor, and all the weights must sum to 1. Then you have to evaluate each location by each factor and then give a score to each alternative. And then multiply the weight with the score and sum up the composite score for each alternative. And then choose the alternative with the highest score. In this case, alternative 2 has the highest score of 82.7, which means the alternative 2 is the best. The last method, the center of gravity method, it is the method for locating a distribution center that minimizes distribution costs. It treats distribution costs as a linear function of the distance and the quantity shipped. The quantity to be shipped to its destination is assumed to be fixed. The method includes the use of a map that shows the locations of destinations. The map must be accurate and drawn to scale. A coordinate system is overlaid on the map to determine relative locations. This is an example of using the center of gravity method. From the left, there is a map that shows destinations. Then overlay coordinate system onto the map. And then use the coordinates of each destination to calculate the center of gravity. If quantities to be shipped to every destination are equal, you can obtain the coordinates of the center of gravity by finding the average of the x coordinates and the average of the y coordinates. This is the formula for the x coordinates and the y coordinates, where n is the number of destinations. Let's take a look at an example. There are 4 destinations, D1, D2, D3, and D4. And each destination has its own coordinates. For example, D1 has a coordinate of 2 and 2. The sum of the x coordinates equals 18 divided by the number of destination, which is 4. We have the average of the x coordinate of 4.5 and the average of the y coordinates of 4. That means the center of gravity of this problem is 4.5 and 4. Which is located near the destination D3 in the figure B and figure C. When the quantities to be shipped to every location are unequal, you can obtain the coordinates of the center of gravity by finding the weighted average of the x coordinates and the average of the y coordinates using the following formulas, where Qi represents quantity to be shipped to each destination. Let's take a look at another example. This time, the quantity shipped to each destination are not equal. For example, destination D1 with coordinate 2 and 2 requires 800 units to be shipped to its destination. But destination D2 requires 900 units. The total of the quantity shipped to all destinations equals to 2,000 units. By substituting the numbers in the table into the formula, we get the average x coordinate of 3.05 and the average y coordinates of 3.7. That means the center of gravity is at the coordinate 3 and 3.7, which is near the destination D2.